All right, so in the previous problem, we helped you to determine the greatest number of fruit baskets. And so we're going to continue that with this problem here. It says, you help determine the greatest number of fruit baskets that can be created and the greatest number of teams that can be organized. A common factor is a factor of two or more numbers. The greatest common factor is the greatest factor two or more numbers have in common. Determine the greatest common factor using prime factorization. So prime factorization is using the factor trees, which you may have seen in a previous grade. So we're going to use prime factorizations for 24 and 36. So the first thing I'm going to do is I'm going to write 24. And I usually start with 2, but you can start with another number. And you factor it out. So 2 times what number gives you 24? 12. We can break up 12 to 2 and 6, and then we can break up 6 to 3 and 2. And once we have all prime numbers, meaning a number that cannot be broken down any further, we are officially done with our factor tree. So let's go ahead and do the same thing with 36. I'm going to break it up to 2 and 18. 18 can be broken up into 2 and 9, and then we have 3 and 3. So right here we are prime factored out. We have prime factors for both numbers. So we are completely done with this step. Part B says, what factors are in common to both 24 and 36? Now, we can find some of the common factors here in the factor tree, but we don't see every factor. So what we're going to have to do is go back and use our factor rainbows. So some of the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then it stops there because 5 does not go into 24. And then let's do the same thing for 36. 1 and 36, 2 and 18, 3, 12, 4 and 9, and then we have 6. Okay, so what factors are common? Well, we have 1, 2, 3, 4, and 6, right? So these, and then we also have 12 in common. Okay, now what is the greatest common factor of 24 and 36? Well, using the rainbows, we can easily see that the greatest factor is 12. However, how else can we confirm that? Well, we can go back to our factor trees. So when you notice that they have a factor in common, right? A prime factor in common, we're going to go ahead and bring it down here. So I notice that 24 has a 2 and a 2. So I'm going to cross them out here, and I'm going to bring down that 2. I also notice that they have another 2 together. So here's 1, 2, and here's another one. So I'm going to bring down another 2, okay? And the operation that we're going to be using is multiplication. Let's see if they have any other common factors. So here we have a 3, and we also happen to have a 3 over here. So I'm going to bring down the 3. And our last one, we have a 2 and a 3. Those are not in common. They do not share that one. So I'm not going to touch those. I'm not going to cross them out. That's all they have in common. So they have a 2, another 2, and a 3. And I'm going to bring all those prime factors down right here. Okay? What I'm going to do with these is I'm going to multiply it out. 2 times 2 is what? 4. Perfect. And then 4 times 3 will give me 12. This confirms what I found through my rainbows, right? I could tell from my rainbows that 12 is the greatest common factor. And by using the prime factorization, I can also tell that 12 is my greatest common factor. So what is a rule that we can use to determine the greatest common factor from a set of numbers once we use the prime factorization? Well, we can find the prime factors that they have in common and then multiply them all out. So here I found that they had 2 2's in common, which gives me 4, and they also had 3, that gives me 12. What is the least common factor of 24 and 36? When we go back to our factor tree, or excuse me, our rainbows, we notice that the smallest factor is 1. Now when we make our trees, we don't include 1, but in our factor rainbows, we do. And for any set of number, you can determine that the least common factor is going to be 1. So for this question 6 where it says, what is the least common factor for any two numbers? The answer is always 1 because 1 is divisible to any number. So the least common factor is always going to be 1. Now what I want you to do is go on over to page 73. I want you to try problem 7 and 8 using either prime factorization or the factor rainbows to determine the greatest common factor of each pair.